Hello everyone, welcome back to our channel. In today's video, we will be discussing about our first topic in pre-calculus, entitled Conic Sections, particularly about circles. So this is a very interesting topic, guys, so I hope that you are going to listen carefully on our discussion from the very beginning towards the end. So let's get started. So hello everyone, welcome back to our channel. Now this time, let's start with the first lesson of the subject pre-calculus. So this is entitled Conic Sections. So from the term cone, so what comes into your mind? If you hear the word conic sections, so from the word conic, you can think of the term or the word cone and sections that tells us, or that gives us an idea that it's a part or a portion of a cone. Conic sections meaning it's a part or a portion of a cone. Now in that picture, as you can see, you have there the double cone. If you are familiar with parabola, then you have also a circle, then you also have an ellipse, and you also have the hyperbola. Okay, but so for you to understand better, let's continue our slide first. Okay, so what are conics? Conics or conic sections are the intersection of a plane with an infinite double cone. Now if the plane, or if that plane cuts both cones, it is called hyperbola. If it is parallel to the edge of the cone, you get a parabola. If neither is the case, it is an ellipse. So the ellipse is also a circle if the plane is perpendicular to the altitude of the cone. So let's take a look at some pictures of the conic sections that is being cut. Okay, when a double cone is being cut, so you have there the conic sections form. Again, you have the parabola, you have the circle, you have the ellipse, and you have the hyperbola. So the four basic conic sections all are created by cutting a double cone at different angles. So that is why it is called the conic sections. Okay, I hope you understand the concept of conic sections. Now, we have the so-called curves and sections in our nature. Concrete examples are spherical, cylindrical, and conic cuts. Those are the concrete examples of curves and sections that we can see in our everyday life. If you have semi-abstract concepts, those represents the figures of conic sections. Okay, and when we say abstract conceptualization, that is the time when we're dealing with equations. It is always better to start new concepts from concrete, semi-abstract to abstract sequence. So in the context of conic sections, we can show plenty of daily life examples of circular, cylindrical, and conic sections, and slowly relate them into four conic shapes, and finally introduce the equation as abstract concepts. So we have here the various circular cuts. You're all familiar with this. You have seen this in our daily lives. So discussing different sections of spherical and sphere and cylinders, convincing them every spherical sections are circles. What shapes are there and what types of sections are formed? Okay, you got there the watermelon. It's spherical in nature, but when it's cut, you can see circle, as well as the oranges, the glass of tea. So you can see on the pipe. So you can see there's our particular various circular cuts that we can see in everyday lives, in our everyday lives. So the various elliptical cuts, we also have this. Is it possible to cut elliptical from sphere? And what shapes are possible from cylindrical sections? So you can also have that. That's cylindrical. That's elliptical cuts. Okay, let's continue. So various conical shapes. Can we cut circular sections in cone? Can we cut elliptical sections in cone? Is it possible to get other types of sections? And what type of cones are possible? So take a look at the figure. The red one, as you can see, that is actually the circle. The one, there's a cone. And then the green one, you have the ellipse. And the and we have the purple one, you have the parabola, and the orange one, you have the hyperbola. If there's also another section being cut, going, if that's downward, if there's another one going upward. Then the cone. Mostly we can see the diagram depicted in right circular cone, but theoretically cones are defined much broader. A cone is a surface generated by a straight line which passes through a fixed point called vertex and intersects a given curve. So there's a person named Robert J.T. Bell in 1910, an elementary treatise on coordinate geometry of 3 dimensions. So that is coming from him, that kind of saying about cone, or the concept about cone. Then the various conical shapes, we're done with this one. Then we have here the cone continuation. Our special attention goes to circular cones. So when the curve is circle, the cone is called circular cone. The line joining vertex and the center of the circle is called axis of the circular cone. So we call it, that's the right circular cone. Then when the axis is perpendicular to the plane of circle, the cone is called right circular cone, and when the axis is not perpendicular to the plane of circle, it is called oblique circular cone. Here we take right circular cone as a standard cone. So we'll be focusing the right circular cone. So there are parts of the right circular cone. Okay, just familiarize with this parts of the right circular cone. So you have there the axis line and the generator line. You have the semi-vertical angle. You have the vertex, the topmost of it. You have the height, the vertical one, towards the center of the circle, to the vertex. Then we have the base circle, and then the base radius. Okay, so the semi-vertical angle is uniform or constant in right circular cone, but it is not uniform in oblique circular cone. Single and double napped cones. Okay, the single napped cone is the one on the left, while the double napped cone is the one on the right. Now for conic sections, when a plane cuts a right circular cone, there are multiple cases of intersections. So degenerate cases, plane passes through vertex. So degenerate conics. Cutting through vertex only, we can come up with a single point. Because it is a double nap cone, and the two cones that are being connected with a point only. So when there's a plane that passes through that vertex, there is only a single point that has been formed with that plane. And then tangent to the cone, so we come up with a line. We have a line, or a single line. When we say tangent, that only touches the cone in one point, or at one point. Then cutting the cone but passing through the vertex, we can come up with a pair of line. A pair of line. Now this time, we have mentioned about 4 conic sections, but for this video lesson purposes, we are going to only tackle the first concept, which is circles. So are you familiar with circles? So when you were still in the junior high, you have discussed circles already, the parts of it, and concepts behind it. Okay, so we will just try to recall the definition of a circle. Now, a circle is a locus of all the points equidistant from a fixed point to the outer boundary. Okay, so you have that figure. That is a circle. The fixed point is called the center. So that is the center to any point on the circle. We call it radius. And the line segment that passes through the center, connecting 2 points of the circle, or any 2 points of the circle, is called the diameter. Diameter doubles the radius, or radius is half the diameter. Okay, now we have here example circles in real life. So you can see in the picture, on the pictures below, you have the wheel. You have also where you can see circles in our surroundings. On the playground, okay, you can see that on the playground, the circle shape in there, the picture of Earth, or planet Earth. Though we know that Earth is spherical in nature, but if we're going to take a photo of it, the picture looks, or with a circular shape. The steering wheel and the logos of different companies. So they usually use circles. Now let us proceed to the standard form of a circle with a center at 0, 0, and a radius r is x squared plus y squared is equal to r squared. The example would be, if you have the center 0, 0, or the center is at the origin, and the radius is 4 units, and you are asked to find the standard equation of that circle, you have that graph at the right, you have the x and the y axis, the radius is 4 units, so that is the graph based on the given information. So if we're going to come up with the standard equation, we will have x squared plus y squared is equal to 16. Why 16? Because r represents the radius, and we need to square r. That is 4 squared, which is 16. Therefore, you have x squared plus y squared equals 16. That's the equation of a circle whose center is at 0, 0, or at the origin with a radius of 4 units. Very simple. Okay. Now, how about the standard form of a circle with a center at HK and a radius r? Okay, meaning the center is no longer at the origin. So this would be now the standard form of a circle. You have to take note of this. You have the quantity of x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. The only thing that is that differs from the previous equation is that the center is given, in which the center is no longer at the origin. So you have the center is hk. So if you have the center 3, 3, coordinates 3, 3, the radius is 2 units. And then if you are asked to come up with a standard equation, so you will have x minus 3, because your h is 3, quantity squared, plus y minus 3, just simply substitute k, which is 3, then quantity squared is equal to, the radius is 2. Okay, the radius is 2. There should be square there on the last part of 2. The answer should be x minus 3 quantity squared plus y minus 3 quantity squared is equal to 4, because the radius is 2 and 2 squared is 4. Okay, that's typo error. And in order for you to graph, all you have to do is locate the center, the point, that is 3, 3. Locate that on the Cartesian plane, that is on the first quadrant, obviously because both are positives. And then, since the radius is 2, from 3, 3, you have to move 2 units to the right, 2 units upward, 2 units downward. That's from the center. Then 2 units at the left. Then you are going to draw or connect the 4 points and create a circle. So that's the process of graphing a circle. Okay, so let's continue. Now, the standard form again of a circle at the center 0, 0 and a radius r is x squared plus y squared is equal to r squared. If the radius is 2 and the center is 0, 0, your equation would be x squared plus y squared is equal to 4. Okay, so that is quite similar to the previous example. And similar also to the previous. This is actually same. This exactly the same problem of the previous example. And the answer is x minus 3 quantity squared plus y minus 3 quantity squared is equal to 4. The one that I told you that there's a correction, this time this is the correct one. Okay? So that is how we graph the circle based on the given information. Now let's have this one. I want you to help me analyze this one, finding the center and the radius when given the equation. Now number 1, x squared plus y squared is equal to 25. Find the center and the radius. So if the equation of the circle is x squared plus y squared on the left side, automatically the center will be at the origin. So obviously the center will be 0, 0. And if you are asked to find the radius, all you have to do is get the square root of the number on the right side of the equation. Since you have there 25, square root of 25 is 5. Number 2, x squared plus y squared is equal to 100. Obviously, the center is 0, 0, and the radius is square root of 100, that is 10. Number 3, the quantity of x minus 5 quantity squared plus y plus 4 quantity squared is equal to 49. So the center would be hk. Remember hk, the standard form of a circle when the center is at hk. So x minus 5, the center would be 5, that's positive 5 and negative 4. So why is it negative 4? Remember the given standard equation is x minus h quantity squared plus y minus k. Thus, the operation is minus. So when the given equation is already plus, then therefore it gives us an idea that the coordinate of the center is negative. So if it is x minus 5, automatic, it's positive 5. If it is y plus 4, then k is negative 4. And the radius would be the square root of 49, which is 7. Okay, let's continue. Number 4. The quantity x plus 7 quantity squared plus y minus 3 quantity squared is equal to 3. So the center is, since it's x plus 7, the opposite sign, you have negative 7. And y minus 3, since it's already minus, so you have positive 3. The center is negative 7, 3. And r, the radius is square root of 3. Okay, number 5. X squared plus y minus 1 quantity squared is equal to 12. Since x doesn't have a grouping symbol, there's no parentheses in there, so it gives us an idea that the x coordinate of the center, or the h, is always 0, if that's the case. So the center would be 0, and then that's h, the h is 0 and the k is 1. So you have 0, 1, and then the radius is square root of 12. Okay, next, number 6. X minus 3 quantity squared plus y squared is equal to 81. So the center would be 3. And then since it's y squared, there's no parentheses also, it gives us an idea that k, the value of k is 0. So the center is 3, 0. And then the radius is the square root of 81, which is 9. Okay. I hope everything is clear so far. Now, if you have, let's continue more examples. To have more examples, we have x minus 2 quantity squared plus y plus 1 quantity squared is equal to 9. For example, if we are asked to come up with a general form or general equation of a circle, because we discussed already the standard form of a circle, now let's proceed to the general form. How does it look like? Now, for the standard form, that is x minus 2 squared plus y plus 1 quantity squared is equal to 9. Okay? That is if the center is at hk and the radius is 3. So, to make it in general form, all we have to do then is do like this one. So, x minus 2 quantity squared, we need to expand that one. Remember, file method. X minus 2 times x minus 2, that gives us x squared minus 4x plus 4. And then y plus 1 squared, or y plus 1 times y plus 1, that is y squared plus 2y plus 1. And then, copy x squared minus 4x plus 4. You just simply extract all the grouping symbol or the parentheses. So you have x squared minus 4x plus 4 plus y squared plus 2y plus 1 is equal to 9. Then, you have x squared plus y squared is minus 4x plus 2y minus 4. Then is equal to 0. Why is it becomes minus 4? So that is 4 plus 1 is 5. Okay, the one on the left side of the equation. And then 9 is being transposed to the left side. So that becomes 5 minus 9. 5 minus 9, that gives negative 4. And then you have there the guide that the general form follows the pattern x squared plus y squared is equal to cx plus dy plus e is equal to 0. So we have x squared plus y squared minus 4x plus 2y minus 4 equals 0. Wherein our c, d, and e are constant. These are numbers, constant real numbers. Okay, I hope that is clear. Okay, let's proceed. Let's have another example. General to standard form. Now, how about if it's the other way around? We are given the general form and then we are asked to come up with a standard form. How are we going to do it? So, if we have here x squared plus y squared minus 6x plus 8y plus 24 is equal to 0. That is the general form of a circle. Then what we're going to do is we are going to arrange similar variables. So x squared followed by minus 6x, then plus y squared, So rearrange the terms. Then followed by plus 8y is equal to negative 24. That positive 24 is being transposed to the other side. So it becomes negative 24 on the right side. Next, we need to complete the square. So we have here x squared minus 6x. To complete the square, that becomes, this is how you're going to do. So just negative 6 divided by 2, that's negative 3. Then square it, negative 3 times negative 3, you got positive 9. Okay? Then same is true with y squared plus 8y. That is 8 divided by 2, that is 4. Then 4 squared, that is 16. So whatever you added to the left side of the equation, that's the same numbers that you're going to add on the right side. So you have x squared minus 6x plus 9 plus y squared plus 8y plus 16 is equal to negative 24 plus 9 plus 16. You also have to add that to the other side. Then it's already a complete binomial. It's already a perfect square binomial. So x squared minus 6x plus 9 is factorable by x minus 3, quantity squared. And then y squared plus 8y plus 16 is also a perfect square. We have a y plus 4 quantity squared is equal to 1. Okay, so that is now a standard form of a circle. I hope you were able to follow. Okay, let's continue. Let's have more examples. Find the general equation of the circular pool of hardened apostema whose center is at the origin and has a radius 5 meters. Okay, so first and foremost, we need to keep or write down the given information. The center is 0, 0 because it says that the center is at the origin. And the radius given is 5 meters. Therefore, what is the standard? The standard form of a circle, we need to start from the standard. You have x squared plus y squared is equal to r squared. That is if the center is at the origin. So x squared plus y squared is equal to 5 squared. Then x squared plus y squared is equal to 25. Since we are asked to write the form, the general equation that is in the pattern of x squared plus y squared plus dx plus ey plus f is equal to 0, the answer would be x squared plus y squared minus 25. We just simply transpose minus 25 is equal to 0. Okay? Now, it is already the general equation of the circular pool of hardened apostema resort with a center 0, 0 and radius of 5 meters. So, in the equation, our value of D is 0, E is 0, and F is equal to negative 25. Okay. Let's continue. How about this one? Write the general equation of the circle whose center is 3, 0 and radius is 2 square root of 2 units. So you're given the center and the radius. You are asked to get the general equation. Of course, we need to start always at the standard form. You have the standard form is x minus h squared plus y minus k squared, but we are already given the vertex is or the center is 3, 0. Automatic, that's why we don't need to write y minus 0. Just y squared is equal to r squared. Then our h is 3, so we substitute that. Then copy plus y squared is equal to 2 square root of 2, that is our radius, and then we square our radius. So I have x minus 3 squared plus y squared is equal to 8. How come it becomes 8? Again, we are going to square the radius. 2 square root of 2 times 2 square root of 2. That is 2 times 2 is 4. Then square root of 2 squared is positive 2. The 4 times 2 is 8. Then we are going to expand x minus 3 quantity squared. That becomes x squared minus 6x plus 9. If we're going to FOIL method, copy plus y squared is equal to 8. Then transpose 8 to the other side. We have x squared minus 6x plus 9 plus y squared minus 8 is equal to 0. Then follow the general equation pattern. You have x squared plus y squared minus 6x plus 9 minus 8 equals 0. And then to finalize our answer, we have x squared plus y squared minus 6x plus 1 is equal to 0. So our D is negative 6, our E is 0, and our F is positive 1. Okay, let's continue. Let's have another example. How about write the equation of a circle with the ends of a diameter at 216 and negative 2, negative 2. Okay, now there are particular problems of a circle in which it will require us to recall the different concepts, formula that you have learned in your junior high, like midpoint formula and distance formula. Okay, so these are very important, class, for you to familiarize this kind of formula when we're dealing with circles. So use the midpoint formula. So if you are given 2 points on a Cartesian plane, we can actually solve the distance using the distance formula, and we can also solve the center of it using the midpoint formula. So the midpoint formula to find the center is just very simple. You have that x sub 1 plus x sub 2 all over 2. Then that would be your h. Okay, then y sub 1 plus y sub 2 all over 2, that will represent your k. Then you are going to simply substitute the values. So x sub 1 is 2, and then the x sub 2 is negative 2. So you have 2 minus 2 all over 2. Then your y sub 1 is 16, and then your y sub 2 is negative 2. So you have 16 plus negative 2, or 16 minus 2 over 2. So that gives you 14 over 2. So 0 over 2 is 0, and then 14 over 2 is 7. Therefore, the center is 0, 7. Okay, so we already have HK. Now this time we don't know the radius yet, but we are given the diameter. Okay, remember the diameter is actually twice as length as the radius. There's another way of solving for the radius directly because we already know the center. That's 0, 7, and we're going to use the distance formula 0, 7, and any of the points given at the diameter. We can solve for the radius. But to be safe, when solving problems like this, we need to always manipulate what is given. Because what if the one that we have solved, for example, using the midpoint formula, we already committed some errors in there. So obviously, if that's the case, if our center is wrong, then it would follow that the distance, the rest will be wrong if we're going to use that and the one that we have solved. Okay, so we have to stick what is given, and we're going to manipulate that in order for us to solve for the remaining unknown. So use the distance formula to find the radius. So to find the radius, okay, so that's what I've told you, that the diameter is 216, negative 2, negative 2, that is the end points. We can solve the distance formula and we can divide it by 2, or just simply use the given that we solved, the center, 0, 7. So although I encourage you to manipulate what is given, so to be safe, however, in this example, we will just be using the center, considering that we are very sure and we are accurate of our answer of our center. So we have here the distance is equal to this quantity x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared. So the points given is 0, 7, and 216. So we just simply use 216 and 0, 7. And we need to label, which is x sub 2 and x sub 1. So our x sub 2 is 2 and our y sub 2 is 16 in this case. Then our x sub 1 is 0, the center. Okay, focus your attention on the coordinates that we have solved of the centers. That is 0, 7. So that would be our x sub 1 and y sub 1. And we're going to substitute the values of using the distance formula. Therefore, the radius is equal to 2 minus 0, because our x sub 2 is 2. Our x sub 1 is 0. Then copy quantity squared plus our y sub 2 is 16. Our y sub 1 is 7. Then copy quantity squared. Then radius r is equal to the square root of 2 squared plus 9 squared. R is equal to 2 squared is 4 and 9 squared is 81. Our radius is square root of 85. And then to solve, to get the equation, you have x squared, because the center is 0. So no need to write x minus 0. So you have x squared plus y minus 7. That's y minus k. Y minus 7 quantity squared is equal to the square root of 85 square, because our formula is r squared. So square root of 85 squared is 85. Therefore, our answer is x squared plus y minus 7 quantity squared is equal to 85. So it's not given as to we are going to give the general form or standard form of the equation. However, we just assume that since it says to write the equation, we just give the standard equation. Okay, so you were able to follow. Okay, another example. Now graph y squared minus x squared plus 36 and identify the radius of the circle. Now the solution would be step 1. Rewrite the equation y squared is equal to negative x squared plus 36 in standard form as x squared plus y squared is equal to 36. Step 2. Identify the center and radius. Then from the equation, the graph is of a circle centered at the origin with radius r is equal to square root of 36, which is 6. Okay. So with that equation, the radius is the center is at the origin. So that's 0, 0. Then draw the circle. First, plot several convenient points that are 6 units from the origin, such as 0, 6, 6, 0, 0, negative 6, and negative 6, 0. Then draw the circle that passes through the point. So just like on the graph. So that is how you are going to graph given the equation. Okay. So that is just simply very easy. This is the simplest example on how you're going to graph given the standard equation, given the equation of a circle. Okay. Another, graph the equation and identify the radius of the circle. You have x squared plus y squared is equal to 9. Very simple. This is a standard equation. So you have equation is in the standard form, x squared plus y squared is equal to 9. First, identify the center and the radius form the equation. Being formed by the equation, and the graph of a circle is centered at the origin with radius r is square root of 9, which is 3. So draw the circle. First, plot several convenient points that are 3 units from the origin, such as 0, 3, 3, 0, 0, negative 3, and negative 3, 0. Then draw the circle that passes through the points. Okay, very easy. Another, how about this one? The center is no longer at the origin. This is still simple though. So you have here, write the standard equation for a circle given by x squared plus y squared plus 6x minus 4y minus 3 equals 0. And state the coordinates of its center and give its radius. Then sketch the graph. Now the given is a general form of an equation. All we have to do is, we can only graph the equation, we can only graph the circle if we are going to express the equation into standard form, from general form to standard form, because that is how we are going to locate and see the center and the radius as well. because we needed this information in order for us to graph. So x squared plus y squared is equal to plus 6x minus 4y minus 3 equals 0. We need to rearrange. X squared plus 6x plus y squared minus 4y equals 3. And then we need to complete the square. X squared plus 6x plus 9. Because again, that is 6 divided by 2. That is 3. 3 squared is 9. Then y squared minus 4y. That's negative 4 divided by 2. That's negative 2. Negative 2 squared. That is positive 4. Then copy equals 3. Whatever we added to the other to the left side, also going to add that to the right side. So that becomes 3 plus 9 plus 4. That gives us 16. So the standard form now of our circle, the standard form of the equation is x plus 3 quantity squared plus y minus 2 quantity squared is equal to 16. Therefore, we can locate the center. The center is negative 3 and positive 2. And the radius is square root of 16, which is equal to 4. So we need to write center, we need to locate center negative 3, 2. So that is in the second quadrant. After locating, we need to count 4 units to the left, to the right, 4 units from negative 3, 2, from that center, from the point. And then 4 units upward, 4 units down, 4 units left. Then form or sketch the graph of that circle. So that's it. Okay. Let's have another example. Write the standard equation for the circle given by x squared plus y squared minus 2x plus 2y minus 7 equals 0. State the coordinates of its center and give its radius. Then sketch the graph. If you have your x squared minus 2x squared plus y squared minus 2x plus 2y minus 7 equals 0. Again, we need to rearrange the terms. You have x squared minus 2x, then y squared plus 2y. Copy equals 7. Then to complete the square, you have x squared minus 2x plus 1. Because negative 2 divided by 2 is positive 1. 1 squared is 1. Same is true with 2y. We are going to look at the numerical coefficient only. So 2y, the numerical coefficient is 2. So 2 divided by 2, that is 1. 1 squared is 1. That is for us to find the third term to complete the square. So there's 1 plus 1 that is being added on the left side. We're going to add the same thing on the right side. So we already have 7 there. Then add plus 1 plus 1. So we already complete the square. That is x minus 1 quantity squared. Then y plus 1 quantity squared is equal to 9. Therefore, the center is at 1, negative 1. And then the radius is 3. Because square root of 9 is 3. Okay. So for us to locate the points or graph, we need to locate 1, negative 1. And then we are going to count 3 units. 3 units up, 3 units down, and 3 units left and right. Then sketch the circle. Okay. Let's have another example. Write the standard equation for the circle given by x squared plus y squared plus 6x minus 4y minus 3 equals 0. And then state the coordinates of its center and give its radius. Then sketch the graph. So x squared plus 6y plus 6x minus 4y minus 3 equals 0. Then we need to rearrange the terms. X squared plus 6x plus y squared minus 4y equals 0. Then we are going to complete the square. X squared plus 6x. 6 divided by 2, that is 3. 3 squared is 9. Then y, negative 4 divided by 2, that is negative 2 squared, that is 4. Then we added 9 and 4 to the left side. We also going to add that to the right side. That becomes 3 plus 9 plus 4. Then the equation would be x plus 3 quantity squared and y minus 2 quantity squared. 3 plus 9 plus 4 is 16. Therefore, the center is negative 3, 2, and the radius is square root of 16, which is 4. So we need to locate negative 3, 2, and then we have to count 4 units on the right, left, up, and down. Okay. Now this time, I think you are now ready for the assessment. Okay, I have given you enough problems, examples, so you will be guided for the assessment. So for number 1, identify the center and radius of each, then sketch the graph. It's very easy because it's already in standard form. You don't need to translate it or express it in standard form because it's already in standard form. Number 1, you have x minus 1 quantity squared plus y plus 3 quantity squared equals 4. Number 2, x minus 2 quantity squared plus y plus 1 quantity squared is equal to 16. Number 3, x minus 1 quantity squared plus y plus 4 quantity squared equals 9. Number 4, x squared plus y minus 3 quantity squared equals 14. Number 5, y squared plus 4x minus 20 minus 2y minus x squared. So this time it's not in standard form, so you have to express it in standard form first. Find the center and the radius. Number 6, negative 9 is equal to negative y squared minus x squared. Okay, this is also very easy. All you have to do is manipulate the equation. Number 7, 9 is equal to 2y minus y squared minus 6x minus x squared. And number 8, 16 plus x squared plus y squared minus 8x minus 6y equals 0. And use the information provided to write equation of each circle. You have the center, 13 minus 13 and negative 13, and the radius. By the way, I want you to write both standard and the general form of the equation of a circle for 9 and 10. For number 10, center is negative 13, negative 16. The point on circle is negative 10, negative 16. So you are given the idea, you can use the distance formula in order for you to solve for the radius in this. That's already a clue. Okay, so use the information provided to write the standard form equation of each circle. So here you are given the general form, or not really general form for the rest. The rest are not in general form, but you have to express this in standard form. So number 1, 8x plus x squared minus 2y is equal to 64 minus y squared. Number 2, 137 plus 6y is equal to negative y squared minus x squared minus 24x. Number 3, x squared plus y squared plus 14x minus 12y plus 4 is equal to 0. Number 4, y squared plus 2x plus x squared is equal to 25y minus 120. Number 5, x squared plus 2x plus y squared is equal to 55 plus 10y. Number 6, 8x plus 32y plus y squared is equal to negative 263 minus x squared. Number 7, the center is negative 11, negative 8, the radius is 4. Number 8, the center is negative 6, negative 15, the radius is square root of 5. Okay, so that's it. You're going to write that on your pre-calculus activity notebook. And to end this video, let's have a quote. This quote is from Jan von Neumann. The calculus was the first achievement of modern mathematics, and it is difficult to overestimate its importance. I think it defines more unequivocally than anything else the inception of modern mathematics and a system of mathematical analysis, which is its logical development, still constitutes the greatest technical advance in exact thinking. So thank you so much for watching, guys. I hope that you learned something in today's video lesson. And if you have questions, please don't hesitate to write your comment below. And don't forget to subscribe this channel. Bye.